A small plane that has a cruising speed of 233 kilometers per hour is planning to fly from airport P to airport Q, where PQ is 147,399 kilometers, and a steady wind of negative 2120 is forecast for the local region. Let the velocity vector that the small plane should set for the flight be xy kilometers per hour. So we know that it wants to head in a particular direction. So let's say that this vector here is some scalar multiple of 147,399. It won't be the whole of 147,399 because we're looking at what happens in an hour. There's a wind of negative 2120. So this is the velocity of the wind. Therefore, the plane should fly in this direction. So this is x, y. Explain why the square root of x squared plus y squared is 233. Well, quite simply, that is the magnitude of the velocity, which we're told in the question is 233. Now, x minus 21 is 147k, and y plus 20 is 399k, where k is a constant. We've got to explain why. So my diagram here explains why. We can see that xy plus the velocity of the wind, which is negative 120, is going to be some scalar multiple of 147,399. It's a scalar multiple because it's not all of 147,399, but it has to be in that direction. Therefore, the I component gives us x minus 21 is equal to 147k, and the y component gives us y plus 20 is equal to 399k. We're asked to determine another relationship between x and y besides the x squared plus y squared square rooted being 233. We can get that from here. So if we rearrange the top one, we get that k is equal to x minus 21 over 147. If we rearrange the bottom one, we get k is equal to y plus 20 over 399. Well, if they're both equal to k, they're equal to each other. So x minus 21 over 147 is equal to y plus 20 over 399. So we now want to determine the velocity vector xy and hence calculate the expected flight time for the small plane from P to Q. So we can find x and y using these two equations. We can just solve them simultaneously on the class pad. So let's just clear a bit of space, get out the simultaneous equation solver, and we've got the square root of x squared plus y squared. That's going to be equal to 233. And then down here, we've got x minus 21 over 147, and that's going to be equal to y plus 20 divided by 399, and that's solving for x and y. And the one we want is this first one here. we can see clearly from the diagram that we drew in the first place that x and y go in those directions. So we get x is equal to 105 and y is equal to 208. So if we now consider 105, 208 and add on the velocity of the wind, then that gives us 84 and 228. So we know that we're trying to go 147, 399. So if we just do 147 divided by 84, that will give us the time. And if you do that, it's 1.75 hours.